Hi everyone, welcome to Pre-Calculus Chapter 4, Lesson 1, Exponential Functions. In this lesson we're going to talk about what an exponential function is and some applications of it. So let's take a look at our definition. An exponential function is any function of the form f of x equals a to the x. Now the x is the variable, the a represents a constant or a plain number. So this can be 2 to the x power, 3 to the x power, 1/2 to the x power. That is an exponential function. Now, characteristics of an exponential function are that the x-axis is a horizontal asymptote. That means any exponential function that you graph is never going to touch the x-axis, okay, unless you've done a transformation. Most exponential functions will pass through the point 0, 1 because any number to the 0 power is 1. And again, I said most because if you've done a transformation, that will no longer be true. And domain is going to be all real numbers. You're allowed to raise any number to any power that you want. Okay, so domain is all real numbers, and the range is going to be from the x-axis all the way up to positive infinity. And again, that could change based on any transformations you do. Now, I made a separate video on how to graph exponential functions, but we're going to look at other applications of exponential functions. So let's take a look at example 1. In example 1, they just want you to evaluate using a calculator. So it says let f of x equals 3 to the x and evaluate the following. So they want you to take the 2 and make it the exponent, negative 2/3 as the exponent, pi, and then the square root of 2 as the exponent. So pause the video, try and do that, and then I'll show you each one of those on my graphing calculator. Okay, so 3 to the second power, I just hit the exponent there, and I write a 2 as my power. And there it is, 3 to the second power is 9, so the answer to A is 9. And now 3 to the negative 2/3 power. If you have an older operating system, you will need parentheses around negative 2/3. So if your calculator doesn't put you up in an exponent like this, if it just shows you the up arrow right here, you would need parentheses. So I'm going to do parentheses, negative 2 divided by 3. Now I didn't need the parentheses, but I'm showing you how to get them in there in case you do need them. Okay, so negative 2/3 is my exponent. And that comes out to 0.4807 or so. Most of the time they'll give you a value to round to. F of pi, so I'm going to do 3 to the, now you might not see it, but right above this up arrow is a pi button. So if I hit second and this arrow, I will get pi, and I hit enter. So 3 to the pi is 31.544 or so. And again, they should give you rounding directions. Otherwise, you can even just copy the entire decimal. And finally, 3 to the square root of 2. So I'm going to do 3 with the up arrow. And again, if your calculator doesn't give you this exponent, you might need parentheses around that. So to get the square root, notice it's the blue above this x squared button. So I hit second square root, and then I just type a 2 there. And I can hit enter, and I get 4.7288. So those are all the answers to this example. Okay, we have another example where we actually have to figure out what the exponential function is. They give us an x and a y, and we have to figure it out. So let's see how that works. So in this example, they say find the exponential function f of x equals a to the x, whose graph is given. And notice they've given us these ordered pairs here. So what I'm going to do is I'm actually going to create an equation. I'm going to put the 25 right where the f of x is, and I'm going to write equals a to the, and x is 2, so a to the second power. Then I'm going to solve that equation. So here's my work. Okay, so you'll notice I did a square root on both sides. That does work. Sometimes it's a little harder though, and you can always check your answer if you can tell where this 1 point is, because 1 looks like it's up at 5, so that does help me. Anything to the first power is going to be the number you used to have, but sometimes it's a little hard to see. So I did a square root on both sides. I got 5. I know this is not -5, because if it was, -5 to the first power is going to be down here at -5. -5 to the second power is going to be up here at +25. So watch out for those negative symbols. Sometimes they get a little confusing. So my original function is f of x equals 5 to the x. So pause the video, see if you can do the same thing for part B. What to the third power equals 1/8? My equation was a to the third equals 1/8. So I did the cube root on both sides. The cube root of 1 is 1, and the cube root of 8 is 2. So this is 1/2 to the x power. And I did need the parentheses here, because if I didn't have them, that would be 1 to the x power over 2, and that's not allowed. That's not what I mean. I mean, the whole fraction is raised to the power, okay? So we have another example coming up. This is another calculator question. Let's take a look at it, and then I'll bring up my graphing calculator. It says, compare the rates of growth of the exponential function f of x equals 2 to the x and the power function g of x equals x squared by drawing the graphs of both functions in the following viewing rectangles. So let me get my graphing calculator back up here. And we're going to go to the y equals menu. In there, you'll notice the blue function I typed in is 2 to the x power. That's the first one they gave. And the red function I have is x squared. Now let's talk about what these mean. These are your viewing rectangle sizes. So if you press the window button, okay, and I already put the first one in here. The first talks about the min and max for your x values, because that's what comes first here. So you'll notice my x min is 0, my x max is 3. Okay, I skip x scale, then the y min is 0 and y max is 8. So I just go in order of what they gave me here. And now I can look at my graph. Now remember, the blue function was 2 to the x, and the red function is x squared. So now all I need to do is write down what it looks like. It looks like the x squared function is growing faster than the blue function. I can tell that the red line is growing faster because it hits the top of the screen before the blue line does. So it looks like the x squared function is growing faster than the blue function, the 2 to the x power. So let's change the window settings for part B. They said they want the x min to stay as 0, the x max should be 6, the y min should be 0, and the y max should be 25. And all of these would be given in the question. Now I just hit the graph button again, and it'll show me my graph. Remember, the blue function is the x squared function, the 2 to the x function, and the red function is the x squared. Notice what happened. The red function did grow faster for a short time, but now the blue function is winning. It's growing faster. Now, if you can't tell which one it is because you don't have a color calculator, that's okay. Press the trace button. Notice it tells me the equation at the top. This is 2 to the x. So where my arrow, my little cursor here is the 2 to the x function. If I hit the up arrow, it'll take me to the other function. It tells me that that other function is the x squared. So if you have black and white screens, you can just do this. So my conclusion from B is that the 2 to the x function is growing faster. And finally, I'll change the window settings one last time for part C. X min is still 0, X max is now 20, Y min is still 0, and Y max is 1000. Okay, now I'll graph. And here is my graph. There's my blue function, 2 to the x. And here is my x squared function, hopefully soon. There it comes. Okay, and now you can see that this blue function is definitely growing much more rapidly than the x squared function. Okay, so 2 to the x wins in a foot race every time, unless you stay very close to home. So that's it for the ideas about what an exponential function is. Watch the second video to see applications to interest.